see some good stuff, so let's hit the video.
Remember when the class survey is on the distance you are from zero on the number line, so we can get distance to the right or distance to the left, which means I need to write two equations out of this. In my first equation, I draw my bars and write just like this. Remember when I go to equal sign, it's in or. And in my second equation, I draw my bars, making everything on the other side opposite, so it's a negative 3. Easy to solve both of these, 7 subtract it, so I'm adding 7. It's the x is 10 or
Have to.
x is 4. Okay, so easy to solve that. Now write my answers. Since this is an equal sign, since it's a lower, it's going to be in our braces. Smaller than it goes first.
Alright, just try to give you a reminder on how you write everything and all that. Yesterday's answer we wrote involving brackets and parentheses because it had a greater than less than sign. If it's equal to, you don't have the brackets and parentheses because it is on it, so that's when you put it in, that's called set notation with those braces that I don't draw very well. That's what that's called, set notation. I wouldn't mark you wrong if you're not putting that, but remember we talked on the first couple of days about how you never know what your, if you take college algebra next year, what your teacher, how she or he will write things and what will be required. They might write it the way I did, they might write it something different, so that's why we're trying to look at all different ways of writing stuff. Okay? Especially those brackets and parentheses. You know, remember when we did them in Algebra 2, I put open dots or closed dots. So different, remember that, open dots and closed dots, Luis, when you shaded a number line? But now you got brackets and parentheses too. All right, linear inequalities. Oh, sorry, I was smart. Alright, first inequality that we're going to look at there. That says x plus y is less than or equal to 4. The directions for this thing say to graph. That was obvious. I put the graph paper up there. X plus y is less than or equal to 4. So first off, let me reiterate the options you have for graphing that. You could rewrite it in slope-intercept form. We spent time yesterday, day before doing that. Solve it for y. That wouldn't be hard to do. It would just mean you need to subtract that x over there. That wouldn't be a big deal. Or you could plug zeros in. Wouldn't be hard on this one either because that just leaves you with 4s when you plug zeros in. So either way is pretty simple. If I were doing this, I would probably on this one do zeros. That doesn't mean I would do it every time. But on this one, the reason I think that's the easiest, for example, if I plug a 0 in for x, y is already solved for. I don't have to divide by anything because it's a 1y. And it's that way on both of them. If I plug a 0 in for y, x is already solved for. You all see that? So I would look at doing that. I plug a 0 in for x, leaves me with y's 4. We're working at solving it just like an equation. We won't worry about the sign until the end. If I plug a 0 in for y, then x equals 4, right? So there are my two intercepts where that thing is going to cross stuff. So I'm going to go over 0 and up 4. Down on the red ones there. Make my line big. Over 4 and up 0. Okay, so I've got that to connect to make a line. Now, stuff we got to talk about before we connect them because this is not an equals, an equation, it's an inequality. Look at your sign. If my sign is less than or equal to or greater than or equal to, I will connect them with a solid line. Okay? But if my sign is just greater than or less than, I said that in the opposite order I wrote them, I'll connect them with a dashed line. Y'all remember that? This is review stuff. Remember that? That's the difference in the sign there. So we've got the bar, so we connect it with a solid line this time. Let's see if I can hit those points. Oh, let me try that again. That's better. Alright, so my line would look something like that. Now, we're not through. Okay, this is the one of the lessons where you find out I'm even messier than you thought I originally was. If this were an equation, we would be through. We've got our line, but this says x plus y is everything less than or equal to 4. So this is going to involve some shading. So we've got to decide if you got two sides to that line. You could shade on this side of the line, or you could shade over there on that side of the line. Common sense a lot of times will tell you which way to shade, but I'm going to give you a foolproof way to check in case we ever lack in the common sense department. Not that any of you would. Common sense, this is less than. To me, less than looks like it's over here, right? Okay, that's what I would do. Foolproof way is to put a checkpoint in. You can put a checkpoint in from anywhere as long as it's not on your line. So as long as my line doesn't hit 0, 0, that's always going to be my checkpoint. So I'm going to plug a 0 in for the x and a 0 in for the y. 0 plus 0 is 0, so I end up, says 0 is less than or equal to 4. Now here's what you do with that checkpoint once you've simplified. If you end up with a true statement, then that checkpoint needs to be shaded. Okay, so right here, 0 is less than or equal to 4. True, right? So I would shade that checkpoint, which means my common sense was right. I'm going to shade over here. If I'd ended up with something dumb, 5 is less than or equal to 4, my checkpoint's not part of the solution, so it could not be shaded, so I would shade on the other side. Okay? The common sense and our checkpoint both proved, so we're just going to shade on that side of the line. Beautiful. Reads like me. He likes to scribble. Alright, ready to do another one? I got what you need there? Alright, I got x minus 3y is less than 4. Directions say graph. Alright, so you got to decide how you want to graph it. Do you want to solve it for y and get your slope and y-intercept? Or do you want to plug your zeros in? Okay, I'm okay with that. I don't mind, but you remember you can do either way. Okay, so don't think you got to plug zeros in every time. But the girls over there said 0, so that's what I'm going to do. This one is not as cut and dry because you've got going to have a fraction involved, but it's okay. If I plug a 0 in for the x, if I take that x out, leaves me with negative 3y. I don't even go worry about that sign right now. Negative 3y, I'm just going to say is 4. So y would be negative 1 1/3, negative 4/3. Plug a 0 in for y. The second one down here, 3 times 0 is 0, so it does just cancel itself out. So we've got a 4 in that one. Bless you. If, this is just an if in case there's anybody, I don't want to leave anybody out. If you had wanted to solve it for y, I would subtract that x. Negative 3y is less than negative x plus 4 divided by negative 3. Y is greater than 1/3 x minus 4/3. And then you have your slope and your y-intercept. So either way is okay. Okay, you get fractions either way on this one. Alright, but I've got my 2 points that I'm going to graph, and then I'm going to check it with that over on dry erase board to see if it all checks out. First one is over 0, down 1. And 1/3. Okay, I just kind of estimated 1/3 was a little bit between 1 1/2 there. And my second one is over 4, up 0. Okay, now this, if if I graphed with this slope-intercept form, it's telling me it would cross the y-axis. My b is negative 4/3, which would be that point, right? Then from there, I would rise 1 and run 3. So let's see here. Rise 1, run 1, 2, 3. So see how that would fall on that line. So you'll get the same stuff either way. All right, solid or dashed? Dashed, very good. Let me find a dashed line up there. There's a winner. See if I can hit those. Hey, first try. Good scout. All right, now where to shade? Oh, okay. I got an idea. Let's plug a test point in and check it and make sure. I'm gonna, since my line's not touching 0, 0, I'm gonna test that. So 0 minus 3 times 0 is less than 4. 0 minus 0 is 0 less than 4. Hello? Yes, so 0, 0 gets shaded, so I shade up there. Now that's one where my common sense might have led me astray. Because I would see less than and I'd kind of be thinking down here. So it's a good idea to always use a checkpoint to make sure. Alright, now the real fun's fixing to come when we're going to put 2 of these on the same graph. I know it. Good times. This is when I always want to call the art teacher up to look at our scribbling. Alrighty. This one we got x, well, we've already done that, we'll do it again. X minus y is less than or equal to 4. And x is greater than or equal to negative 2. So directions want us to graph that. Alright, so let's do one at a time. We've already dealt with that. X minus y is less than or equal to 4, except ours was x plus y last time we did it, so it is a little bit different. Do you want to do zeros or slope-intercept form? Okay, so I plug my zeros in. 0 in for x leaves me with a negative y is equal to 4. Go ahead, ask me. You can ask. Well, look what I did. I'm just solving it like an equation right now because that's not, the sign is not going to matter until my final. So that gets me y is negative 4 when I plug the 0 in for x. Now I plug a 0 in for y, just takes the y out, positive x is 4. Okay, so we got 0, negative 4, and I got 4, 0. Alright, will that be a solid or a dashed line? Solid, good, because it's got that bar. Good job. Now what I'm going to do, some people wait and do all their shading at the end because they think they can look at it and see where the shadings overlap. Remember, I didn't write it, but when I read this thing to you, I said x minus y is less than or equal to 4, and x is greater than or equal to negative 2. So that and is still a big deal to me there. I'm going to be looking, if this is and, I'm going to be looking for where these two shadings intersect. So some people will wait until they get both lines done to try to keep it neater. Y'all know neatness is never one of my priorities, so I'm going to go ahead and shade that line. Then we'll graph the second line and shade it, and then we'll find our overlapping spots. Austin?
Are you not supposed to flip the signs divided by negative?
That's what Bailey was asking about. And when I actually did that part, I just pretended like it was an equal sign. I didn't even mess with the signs. Yes, technically, the sign would flip, but it'll still go back to the original the original problem when you do your test point. Good question, and Bailey was talking about that over there. Y'all are on the same page on that. Okay, this thing's already solved. What kind of line is it when it's just an x with no y? Yes, vertical. Vertical, very good. So x equals -2, x's move over, so I'll move over to -2, and I'll just be a vertical line through that point. Will my vertical line be solid or dashed? That away, good job. Alright, so we can see if I kept going down there, that these are going to intersect down there, right? Y'all can see that. I'm out of graph paper just about, but there, right? Alright, so, I never shaded the first one. Let's shade the first one. I'm going to do my test point. I'm on the diagonal line, the one with the positive slope. I'm looking at it. I'm going to do my test point in that one of 0, 0. So let's color code here. 0 minus 0 is less than or equal to 4. That's true. So this, with the positive slope, this line will get shaded where 0, 0 is. Okay, now over here on this vertical line, vertical and horizontal lines are our favorites because we don't have to do a test point on those. They are just what the sign says. If I got to be greater than -2, greater than is on the right of it. Okay, try, I know it's difficult, try to make some sense out of that mess. My answer is everywhere the shadings overlapped. So that's what I'm yellowing right now. Everywhere I had green and red, so it's that middle section on that. That's why I tried to go down and show you that the lines were going to intersect. Because where they intersected down there is where my answer would stop. Does that make sense? Like, I wouldn't have anything outside of that intersection, right? When I'm doing these on my paper and I'm like you and I just got a pencil, I just sometimes would try to circle that or make that extra darker, you know, something. Yeah, the more I go, the messier it gets. Okay, so just like when we were on the number line, when we had an and, it was the intersection of stuff. That's what happened there. The and was where both pieces were scribbled, both pieces were shaded. So now we're going to do an or. Okay, got what you need on that beautiful art? It's almost Christmas colors with the red and green. The yellow could be like bells. It's ugly. Somebody I saw had a Halloween decor. Oh, I went to my guitar lesson. They had in the dance studio that's next door. They had Halloween decorations up. I don't think so. You need to at least wait till October.
We put our Christmas tree up in November.
My mom puts hers up the day after Thanksgiving, so I guess that's
We put ours up November 1st.
that's a little much.
Well, that's when we moved into our house when we moved here, and so we just have always put it up with it.
Alright, this time we've got 7x minus 3y is less than 21. Or, notice the or this time, or x is greater than 2. Okay, when we did ors when it was just a number line, when we only had one variable, and you do realize that that's the difference in a number line and a coordinate plane. When there's one variable, it's on a number line. Now we're having two variables, that's why we've got a coordinate plane, an x and a y. Y'all get that right. When we were on a number line and we had an or, it was always a bigger piece that was shaded and restricted it because you had to fit in both. Or it could be either one, so you got more stuff. Same thing here, or it can be either one. So our shaded area is probably going to include a lot more stuff this time. Alright, 7x minus 3y equals 21. I'm fixing to make Katie mad. We're going to do that one in slope-intercept form.
Oh, that's it then.
Just because we need to, because there's some people that like to do that. So I'm going to subtract 7x from both sides. That's going to give me negative 3y. It's less than negative 7x plus 21. Now I'm going to divide everything by negative 3. Here's what Austin and Bailey were talking about earlier. It's going to give me y. I'm going to go ahead and flip it, bless you. It's greater than 7/3 x plus, or excuse me, minus 7.
I have a question.
Did I mess up?
No, I was thinking,
Okay.
if you were to do it the other way, how you were talking about, when you said you wouldn't worry about flipping the signs.
Just with the equal sign. Yep.
Well, but what if like on a test, Kate did it that way and flipped the sign, and I didn't? Would it be different?
No, the only time that it's going to matter is when you plug your test point in to figure out where to shade. You just got to get your info needed to graph. Your line is going to look the same. No matter if you had an equal sign or a greater than sign, you're going to graph your line the same. It's only when you need to shade when that sign matters. Go back to your original problem for that. Make sense?
Yes.
All right, I'm going to have to count on every line on this one to get my y-intercept of -7. So I'm going to go down 1, 2, 3, 4, 5, 6, 7. Then from there, my slope is 7/3. So from there, I'm going to rise 7. So it takes me back to the origin and run 3. Okay, does that line need to be solid or dashed? Dashed, good. Oh, I don't like that one. Let's see which way is this way. Oh, shoot. Struggling. Okay. Alright, now let's see where we need to shade on that one. So this is what I was talking to Bailey about. I'm going to go back to my original equation, inequality. I've got to say it correctly. Back to my original inequality. That's where I'm going to plug my test point in. Now remember, I've been lucky and been able to use 0, 0 every time so far. But if my line ever goes through 0, 0, I've got to pick a different point. You could just move over here and pick 5, 0 or something else. It can't touch the line. Your test point can't be on the line. But this one, 0, 0 is good. So 7 times 0, 3 times 0 is 0 less than 21. Bless you. Yeah, 0 is less than 21. So the section of my line that has 0, 0 in it made it true. So it gets shaded. Any point as long as it doesn't touch your line. Okay, then my other point, my other line, it's another vertical one. X is greater than 2. Will it get a solid or a dashed line? Dashed, good. So 1, 2, it would be through there. Now greater than goes to the right on that. So let me get a new color here. We'll go to the right of that vertical line. Alright, if this had been an and, it wasn't, but just trying to keep it all in perspective. If this had been an and, my answer would be only the part where I had both, which would be in that, right? Am I good on that if that had been an and? But because it's an or, my answer is anywhere at all that got shaded. I only have one spot that did not get any shading. This little section down here did not get any shading, right? Everything else did. So my answer is everything except that. Now, how the heck do you mark that on your paper? Remember, the good news is our test in here are multiple choice, so it'll already be shaded for you. I'll get the highlighter and scribble on it.
How would you drop that though?
You would just need to make it all darker somehow. Just make it. And there's no like interval form answer or anything like that if that's what you're asking. So everything except, let's scroll it down, everything except that is part of your answer. It's beautiful. Not.
That yellow's kind of a color like the mustard or something. Oh.
Honey mustard is good.
Why is Subway and honey mustard
Because honey
gross?
mustard gross.
It
Honey
just,
mustard is amazing.
no, it just doesn't sound good right now.
Gross.
It's good, but not right now.
It's only good at some.
It's morning.
Yeah. Right now, I'm thinking
Well,
about
it's
like
10:55,
pancakes.
so
In like
it's
Starbucks.
11 o'clock.
I got a text. Ladies, what's the name? You don't even gotta worry about it. Louise, I gotta watch her. Austin said he doesn't have service, so you don't have to worry about it. So Louise does.
I do, but I'm not on it.
My phone button lit up when that noise came on, so that's why I checked, but it went.
Alright, I'm gonna let you try this one. X minus y is greater than or equal to 1, or y is greater than or equal to 2. Now, the previous two that we did, it was an x on the second line, so it was a vertical one. This one's a y, so that second line will be horizontal. Austin's got it over there. Alright, try that, see if you can get it done.
That's fine, whatever you want to do.
No way, I still. That one last one is.
Or means that you can like go across like this.
It's the bigger, yep.
You don't put it in zero.
Yep, your test point doesn't make, 0, 0 doesn't make that one.
So then you
So
should.
you can't, yes, you can't shade 0, 0. Just- Now on your first line, that x minus y is greater than or equal to 1, this is the first one where my test point 0, 0 didn't make it true. So when I go to shade that diagonal line, 0, 0 is not true. It can't be part of my answer, so I have to shade on the side of it that does not have 0, 0.
What did you do?
I don't know, I tried to.
I just plugged in the zero because it was already.
Oh, so you did right here.
No, because that way it's
Yep. Yeah, what I mean is when you go and put the test point back in. So that's the right line. That's what you're going to connect. But then when you do 0, 0, 0 is not greater than equal to 1, so you can't shade above it where 0, 0 is. That's what I was talking about.
I just forgot to get over today, so I'm
Why is greater than
Y'all ready, or you need to still fashion it out? Alright, on that first line, x minus y is greater than or equal to 1. If it were up to me on my own, I would plug the zeros in for that one. When it's just a 1x and a 1y, that's what I would do quickest. So I'm going to be finding my x and y intercepts on that. I plug a 0 in for the x. That gives me negative y is 1. So I have to divide by negative 1, and y would be negative 1. Everybody get that? That did it that way? If I plug a 0 in for the y, that just gets me x is 1. Okay, so I'm going to go over 0, down 1, over 1, up 0. Alright, should this line be solid or dashed? Solid, good, sir. Okay, so I got something looking like that. Now this is what I was talking about there while y'all were working. If I plug that test point in, 0, 0, 0 minus 0 is 0. 0 is not greater than or equal to 1. Right? So I cannot shade the part where 0, 0 was. My test point was false this time. So I can't shade that, which means I've got to shade on the other side this time. It's the first one of those that we've seen. Okay, I hinted you with y. Y is greater than or equal to 2. That means I'm going to go up to 2. That'll be a horizontal line. Will it be solid or dashed?
solid?
Solid. Greater than that goes above it. So my answer for this is everywhere that got any shading at all. So that would be all of this, everywhere that got any shading at all. Good?
Great.
Great. Tiger. All right. Where this, I mean, we could do a million of those, but it's not going to do a lot of good. Where this goes next, go start getting into function stuff, telling if stuff is a function, vertical line test, all that kind of stuff. Bless you. That's what we'll be looking at on Monday, because tomorrow we'll look at our ACT stuff. All right?
Yes, ma'am.
All right. Thank you, sir.